In this video, we are going to discuss about the common collector amplifier circuit. So, on the completion of this topic, the students will be able to build a common collector amplifier to insert that is between the source and the load, and they can also measure its characteristics. Also, they can observe the problem of the high output impedance source, which is connected to the low impedance load. Also, they can find out the similarities and the differences between this common collector and common emitter. So in the common collector amplifier, as if no, in the case of the common emitter amplifier, we have grounded the emitter terminal, but in the case of the common collector amplifier circuit, we will be grounding the collector terminal. So here the input will be the base and the output will be the emitter, and this collector region will be grounded. So in this circuit we have considered the voltage divided bias. So since we are considering the voltage divided bias, then there will be the resistors R1, R2 and RE, and also we will be having the input capacitor and the output capacitor, that we call it as a coupling capacitor. So here we don't have any bypass capacitor since we are considering the emitter terminal as an output. So here we can see the output at the emitter terminal and the collector region is grounded. So this coupling capacitor, that is C1 and C2, which is used for passing the alternate signal for amplification, and they will block the DC current. And also here in the case of the resistors, we will be considering the three resistors, that is R1, R2 and RE. And next, from the circuit which we have been seen, that is DC biasing, we have provided by the R1, R2 and RE. Then here the load resistance we are taking, that is the capacitor which is coupled to the emitter terminal. So whenever we are applying the signal to the base of the transistor, that is if we are giving any signal to the input of the base, then the voltage at the base region will be increases, and also due to the increase in the voltage there will be decrease in the signal, which leads to the positive and the negative respectively. So which forms the terminal, that is VE is equal to VB minus VE, which in turn we can say that is voltage, base emitter voltage is nothing but VB is equal to VB minus VE. So from that we are writing as VE is equal to VB minus VBE, since we are finding out the output voltage at the emitter terminal. So we are finding out the VE value. So here we are considering the value, that is VB is constant, that is nothing but 0.7 for the silicon and 0.3 for the germanium. So the variation in this base voltage which is appearing at the emitter and the emitter voltage, it suddenly changes, that is VE will be varying with same as the base voltage, that is VB. So in the case of common collector circuit, we are considering the emitter terminal will be flowing from the signal voltage from the, that is it is connected from the base. So when this signal is flowing from the base region, this it is passed through the emitter terminal. So we finally call this as emitter follower circuit. And common base amplifier circuit. So in the case of the common base amplifier circuit, here we are considering the base terminal as the ground. So here the input will be the emitter and the output will be the collector. So we are in this region. Here also we are the signal source which is coupled to this emitter of the transistor, which we are taking through the capacitor C1, and also the load resistance, that is RL, we are connecting to the collector region, that is connected through the capacitor C2. Here the positive region, that is positive, which is going to this input source, which is increasing with the emitter voltage. So as whenever there is an increase in the base voltage, when we are setting some base voltage as constant, means then the forward bias of this emitter junction will be reduces. So this reduction will causes the base current and collector current to get very low resistance along this region. So from this we can say that is V0 is equal to VCC minus IC into RC. When there is a reduction in the collector current, this tends to the increase in the V output. So positive which is going through the input region will produces the positive which is going through the output region, and also positive which is going to the output region will be giving the input region. So there will be no phase shift between the input and the output region in this common amplifier. And the quiz questions on the common collector and the base amplifier circuit. It is first one is, for a common emitter amplifier, the purpose of swapping is, and second one is an emitter follower is also known as. Third one is, what is the range of the current gain for BJT transistor amplifiers.